Hello everyone. Today we are going to talk about 10.3 unit circle with trigonometry. Yesterday we learned about unit circle, right? But now we are going to use trigonometry here. So do now, I think you can do it by yourself. If you have a trouble with this, you can go back to the video, yesterday's video, right? And you can try. Now, trigonometry. So easy way to remember is SOHCAHTOA, right? What is SOHCAHTOA? SOHCAHTOA, in the right triangle, this is a hypotenuse, opposite of the angle, adjacent to the angle. So depending on where the angle is, your opposite here, adjacent here, right? If your angle is here, then where is opposite? Over here. This is opposite. This will be adjacent if your angle is here. So how do you get the trigonometry value? Sine here, what do you have? The angle measure of the angle, go to the parentheses. Sine is opposite over hypotenuse. And cosine is ka, adjacent over hypotenuse, adjacent over hypotenuse. So we should know that this trigonometry is the ratio of two sides, right? Sine is the ratio of opposite and hypotenuse. Cosine is adjacent and hypotenuse. It's a fraction, the ratio. How about tangent is the ratio of opposite and adjacent. So TOA. So if you know the all three sides, you can get the trigonometry value for that angle, right? So for that angle, you can find out trigonometry values. The trigonometry is what? The ratio of two sides in the triangle. Especially we are dealing with only the right triangle here. All right. So let's go with one example. But in the unit circle, one unique thing is in unit circle, sine the angle. Let's say the angle is here. Sometimes your angle is over here in the second quadrant and third quadrant, fourth quadrant. We'll talk about it soon. With the first quadrant, let's say first, if you, what did I say? How do you draw the vertical line or horizontal line to make a right triangle? This way or this way? Yeah, this way, right? Always draw a vertical line to the x-axis. You make a right triangle here. If you have a, in the quadrant 2, you make a right triangle here, right? Right. So now you have here. And then one leg, this one is x, vertical line is y. Then if you have a sine angle, sine is opposite over hypotenuse. What is hypotenuse in the unit circle? 1. So y over 1, that's a sine the angle. Cosine is ka, adjacent over hypotenuse. So adjacent is x, hypotenuse 1, which is x, right? And tangent is opposite. Oops, sorry. Opposite over adjacent, which is y over x. Y over x. Oh, in here we said sine theta is equal to y. So instead of y, you can write down sine theta. And x is a cosine theta. They are equivalent, right? Y over x in the unit circle, y over x is same with sine theta over cosine theta. Theta means the angle. So either sometimes you need to use this one too, but In the right triangle, if you know the size, the length of the sides, you can use these, right? Let's see. But if you have in the different quadrant, let's see, we are using the reference angles. Your angle is in the quadrant 2, let's say your point is here and in M is the point. Then initial angle and this is what? Terminal ray, initial ray form an angle here, but your triangle is here. So if you use the reference angle, just I will not explain too much about reference angle, but we can use the reference angle 180 degree minus this angle, and you will get the angle A here because we have a right triangle here. So use this angle, okay, which is difference from subtraction from the 180 degree minus original angle here, then you get the angle here, this one. We are so simply we are drawing the right triangle this way. If you draw a right triangle, you will see which angle is the reference angle of original angle here. But x is negative, y is positive in the quadrant 2. We learned yesterday, right? Depending on the coordinate, but always hypotenuse is the same, positive. If you go to the quadrant 3, now your angle, original angle from here to all the way to here. So which angle do you use? The reference angle here. This in the right triangle, the A is the reference angle. We can use this angle instead of this big angle. But answer only sign matters. You don't need to worry about, but only sign, the positive or negative. So x is negative, y is negative. Okay, then you will get the even though the angle is bigger than 180 here. So for example, if you have a 210 degree, now you subtract 180 degree, then 30 degree is the angle here. Instead of 210 degree, you can use 30 degrees, but sign will be the different, right? That's about quadrant 4, your triangle here. So always with your M point is here, then you draw vertical line to the x-axis, you make a right triangle. Your original angle is from all the way to here. This is the angle, like let's say if this is 335 degrees, then your reference angle, which you are using, the reference angle is 360 minus 335, which is, 315 degrees. Let's say 315 degrees. Then 360 minus 315 is 45 degrees, right? We are going to use 45 degrees instead of 315 degrees. Then your, opposite is here, adjacent to here, opposite is again y, adjacent is x, like this. So opposite is always y coordinate, adjacent is always what? X coordinate you are going to use. So let's go with one example. You don't need to worry about this. I already mentioned, but don't worry about. So if you see it, all sin tan cos, just remember all sin tan cos, it's about the sine. So when you finish everything, you calculated everything, the result. In the first quadrant, all trigonometry values, sine, cosine, tangent, they are all, it become positive. But in the quadrant 2, all sin, only sine is positive, cosine, tangent become negative. In quadrant 3, tangent is a positive, only tangent, but sine and cosine become negative. In quadrant 4, only cosine is positive, sine tangent is negative. That way, so if you just solve algebraically, you will get it, the sine positive, negative. But to verify the answer, just remember Olsen tan curve. All right. Let's see with the example. All right. In the question, y is negative half. And you need to solve for x, right? You need to solve for x. Which quadrant? Quadrant 4. Y is negative half over here, and negative half here, right? Then your point is here. How do you draw the right triangle? This way. Yes, you are going to draw a right triangle like this. And you need to solve for x. Now, do you see that x is a positive or negative? Yes, x will be positive. Y, you know, y value is a negative, right? So what do you do? We are using Pythagorean theorem to solve for x. You need to solve for x first, right? Then you can find out sine, cosine, tangent, trigonometry values. So let's solve for x first by using what? Pythagorean theorem, right? X squared plus y squared is equal to what? 1 square. Make sense? Then we substitute negative half becomes y. But make sure when you do the what? Negative numbers or fraction, when you do squares or whatever you do, what did I say? Always put in the parentheses, right? If not, you might get wrong answer. So if you do the square, negative half a square, negative square become positive. Even power become positive, whatever it is, right? And the 1 over 2 is 1 over 4. Now, you move 1 over 4 to the other side. 1 minus 1 over 4 becomes 3 over 4. And how do you solve for x from x squared? Yeah, you do the square root to both sides. But when you do the square root from x squared, how many solutions? 2 solutions, plus or minus. The plus or minus square root to 3 over 4 becomes x. And if you have one square root with a fraction inside, you can separate into the 2 square root in the numerator, denominator. And square root of 4 becomes 2. So x is plus or minus square root of 3 over 2. But we said that in the quadrant 4, x is what? Positive. So you take only positive for x. So square root of 3 over 2. So if you found x value, not just plug, get the trigonometry value. Sine was what? Sine was opposite over hypotenuse, which is y over 1. And you know that this is y, right? Cosine, adjacent over hypotenuse. So adjacent is x, hypotenuse 1, which is equal to x. Tangent, angle, we don't know the angle, doesn't matter, but even though we don't know the angle, we know that there is an angle, right? You don't need to worry about the angle, but there is an angle. But tangent, the angle is equal to what? So opposite over adjacent. To opposite over adjacent. Now you know what is y, negative half over x, square root of 3 over 2. You know how to you know how to divide the fraction, right? You change it to the multiplication and so divisor become, and you get the take a reciprocal of divisor. Oh, let's see it like this. So you got x equal to square root of 3 over 2, right? And y was given. The sine the angle is negative half. Cosine the angle is square root of 3 over 2. There is no problem with this. But when you get the tangent is y over x. So y over x. Y was negative f divided by x is square root of 3 over 2. Well, how do you change it to the multiplication, right? Division become multiplication, and we take a reciprocal over this. The square root of 3 goes down, 2 goes up, and then simplify. When you simplify 2 in the numerator and denominator cancel, then negative 1 over square root of 3. You can just leave like this, but to complete, if you do rationalize the denominator, it'll be much better. How do you rationalize the denominator? You multiply same radical 3 to the numerator and denominator. So numerator, you square root to 3 times 1 becomes square root of 3. And denominator, square root of 3 times square root of 3 is square, right? Square root of 3 is square. And square and square root cancel, it becomes 3. So what tangent angle is negative square root of 3 over 3. So look, even though it took so long, because we found out x first and sine value, cosine value, tangent value. Obviously, they will ask everything together, mostly one of them, right? So, but just remember, you know how to solve for x, and you remember how to find the trigonometry values, right? SOHCAHTOA, TOA, using it, and you can find out sine, cosine, tangent. That's all you are going to do it today. So now if you go down, so you can see the Google Classroom discussion here, right? So go to the Google Classroom and please so find out your answer and respond to the Google Classroom, please. And if you go down, so you have how many questions? 1, 2, 3, 4, 5, 6 questions. 6 questions. Solve the problems in the packet. And you go down here, you have a exit ticket. So finish and take pictures of them and email it to me. All right, let's stop here.